Bismillahirrahmanirrahim. Assalamu alaikum. My name is Jamshed Ali and my role ID is 190994. So today I'm gonna introduce and I'm gonna show some tasks to interface and how can we interface hex keypad using AVR microcontroller. So first of all, the equipments we required are ATMEGA 328p or 2560 whatever, and breadboard, jumper wire, 7-segment display in case of when we have to apply on 7 segment, and hex keypad Proteus AVR Studio. So first of all, this is a basic introduction about hex keypad. It is a simply arrangement of 16 push buttons which is 4 cross 4 matrix. So here you can see 1 2 3 A 4 5 6 P 7 8 9 C 0 hash. So the hex keypad having 8 connections via namely R1, R2, R3 and R4 and C1 and C2, C3 and C4. So these are representing as rows and columns respectively, such as R1, R2, R3, R4 and C1, C2, C3 and C4. So this is the basic schematic of a typical hex keypad. So now this is the some little bit introduction about hex keypad when it is low or when it is high. So it will tell us about our logics. So this is the common 7-segment display schematic. Here we use A, B, C, D, E, F, G and DP. So they are all connected to the common cathode. So our LED we need to connect ground to pin 3 and pin 8 and connect positive wall to the other pins. So pin 3 and pin 8 is connected to the ground and other to the 5 volt, and then individual 7 segments lights up. So this is a basic schematic. So in a common anode, this is the process of common cathode. So in a common anode display, the positive terminal of all the 8 LEDs are connected together and then connected to pin 3 and pin 8. So it is reverse of common cathode. To turn on individual segment, you ground one of the pins. So one of the pins should be ground. So this is the process of common anode. So this is the 7-segment displays of common cathode and common anode. So here we are connected VCC, here we are connected ground, and here we are also connected ground, and here we are connected with VCC. So in common anode we are connected to the VCC, and while in common cathode we are connected to the common ground. So this is the digital bits for displaying decimal on the 7-segment display. When our A, B, C, D, E and F are on, G are off, then our segment will display in case of 0. So when A and D, E, F and G are off and B and C are on, then it will display 1. So and as it is in this manner, it will display all the 9 digits A, B, C, D and E, F till F. So this is the first lab task. So this is the main function of our code which we are going to perform some interfacing of hex keypad on our 7-segment display. So first of all, we have to define the frequency and then include AVR header files and keypad h. This keypad h file is gonna be a header file. So this has its own function which we are displaying on next page. So I will show you the complete code of our keypad.h header file. So this is the function of SMS LCD.h. So this is also our function of for displaying on LCD. In case of LCD, if we are displaying on 7-segment, then we can not be able to use. So first of all, we have to initialize the character temperature number 1, sign number 2 result, and then in the connector the first ray, and then unsigned character test 0 and void clear. So we have to initialize the values to the temperature number 1, sign and number 2. For checking valid operator and operand, we have to integer initialize unsigned character q. If q is less than 10 and q is equal to 77, then it will return 1 and return 0. So it is if unsigned character q is less equal to 88 and q is equal to 77, then it will return to 0 and then 1. So this is the main void function. Here we start our while loop. So with the help of direction register, we are going to set D input, D output and E port as a output port. So here we initialize the maximum value 255 to the DDRD register and DDRE register. Here we call some delay. So after delay we have to clear the ports. So again, while we are creating the while loop, so here our function start number 1 is equal to the our key command, and then it will test to the previous function, which is num function. Mean when q is equal to 88 or q is equal to 77, then it will return to 0 and then 1. After it will our delay function will call, and then if number is equal to 77, now here we are two conditions. If number is equal to 77, then our function will break and start number 1, a1, a1 and 10. So it will display the a1 on our side. So itoa is a command basically used for displaying or other purposes. So now this loop is started for our for when we are getting operator. So sign is equal to key, so we initialize sign, and then test is equal to num is equal to sign. And here also we have two conditions. If sign is equal to 77, then function will break. If sign is equal to 44, then we will call display slash, and else if sign is 55, then it will display static, and if sign is 66, then it will display dash, and if else positive number for getting. So this is for getting first operand. So now we are getting to have second operand. So also as it is in previous case, we have to initialize that as 0 and key, and then test number function, and then if number 2 is equal to 77, then our function will run and it will display a1. And for getting validation, we have to start the next while loop, in which the we have to paste this context, and then after it, if temporary value is equal to 77, then our function will break. If then it will, if sign character is 44, then the result is number 1 divided by number 2, means here division operation will take place. So if sign is equal to 55, then multiplication operation perform, and if sign is 66, then difference operation will perform, and at last if all of these are not, then our summation function will perform. So we have to now call this display is equal to, and then we will get our result with the help of itoa command, and it will display our answer a1. So this is the main code of our hex keypad, and now this is the keypad of dot keypad header file which we are creating in our main function. So this is the header file for our keypad. So now you can see we have to initialize AVR header file standard, and then frequency setup, and then delay function, and with the help of output direction register and output port, and input direction register input ports, we have to define all the input and output ports. And after character key, we have to unsigned character register is equal to 11, and then unsigned character we have 11 arrays. So this is simply 11 arrays, 0 1 2 3 4 5 6 7 8 9 and 10, starting from 0 to 10. So we are here creating output was equal to 0xff maximum value, and then character temperature, and then here from here while loop our start, and in which the first row for 1, and if input port is equal to 0x0f, then another IPP is equal to 0x01, and then temperature temporary value will set to the IPP IN, and if temporary value is equal to 0x11, then our IP is equal to 0x0, and IPP is equal to 0x10 will print out. And if our temporary C value is equal to 0x11, then our RECS value is 1, and then our operation A1 array 1 operand means 0x31 0x31 will display, and our after it our function will break, and our number 1 will end. So this is all as it is for our number 2. Here also we display 0x0f 0x02, and then it will display to the our IP function, and then our by setting temporary value, it will if function is equal to 0x12, then it will call this function, and the array will display the second which our function is 0x12, and after it our number 2 will end. So this is the basic as it is for our number 3. Here we call 0x14 in the operation, and when it detects 0x14 temp c value, then our function will break. So as it is for our next number, also we call 0x18, and then as it is for our next 4 number, we call 0x21. In our temporary c value, if it appears it, then it will display our function. So now this is our number 5. For our number 5 input, here we call 0x22, and for number 6 we call 0x24, and numbers again number 7 we will call 0x28. So these are all outputs for our total 9 numbers. And if we have to create sign such as multiplication and operation, division operators, then it will call some function 0x41, which is keypad input, and then it will display the temporary c value on 0xff, and then the array will print out our function which will displaying on our 7 segment. So now we have to print the number 8, which we are going to print on our 7 segment, such as the 0x42, which is the 8 elements of our creating array. So as it is for our creating array 9, and then as it is for our last digit, which is 10. So now we are moving towards our row 4, which is starting from 0, mean 4 numbers. Row 4 also containing 4 numbers, static a, b, c, or etc. So for first number means 0 number, we have to print out 0x82 in this context, and then for next number equal printout, we have to print 0x84, and then after it will, when it detect c port, it will break our function, and then we have to perform, if we are going to perform summation, then our function will call 0x88, and if it detects 0x88, it will display our NAND function, and after it will breaks. So for equalizing, it will at last compare our function. If IC value is 11 or 22, and else if port B is equal to 0, then break. If it is equal to 11 or 22, then port B is equal to 0, and after it our function will return to the our key 1. So at last, if it is not detected, then port B is equal to 0, and after function will return. So this is a basic Proteus simulation of our hex keypad. So I'm going to show you on Proteus, such as I'm running the hex file of our this hex keypad code on this Proteus simulation, such as I'm going to print 1, then it will print 1, and then it will print 2. So in this manner it will display the number on our hex keypad 7 segment display. So this is the basic interfacing of our hex keypad on our 7 segment display. So now we have to write a code to interface hex keypad with ATMEGA and glow any LED with the input from the keypad. You must have to do its simulation on Proteus. You must have to implement the hardware on breadboard. So this is the basic code which we are going to perform to glow our LED when we are pressing some hex keypad input button. So now you can see first of all we have to unsend character initialize all the array, and then with the help of DDRC we have to set the direction register C port output, and then initial character initialize temp R value temporary C value. So this is all the basic, as it is same code as we have performed in our simulation hex keypad interference while performing on 7 segment. So in this simulation, we are going to remove our 7 segment display, and here we are going to attach our LEDs. So this is all the basic same code which we are performing on our hex keypad, and then you can see we are just have to show the Proteus simulation on our 7 segment display or LEDs as well, to get our output, such as I am performing when this fill function will return 2, and then we. So this is the basic Proteus simulation of it. If I am going to perform this, then it will display 1, and as it is in this manner. So this is the basic Proteus simulation, and this is the basic code of our hex keypad for performing on our Atmel Studio and AVR microcontroller on hardware as well. So on hardware, we are going to perform the hex keypad with resistors and LED segment by using Arduino 2560. So that's all from our side.